Good morning. Good morning. Good morning, all. So, all are welcome to my session. Today, we are going to discuss about 8051 microcontroller instruction set and programming. Uh, First of all, before going to have a discussion about what about the instruction set and programming, at least we need some syntax or it may be a structure of assembly language. So, it indicates a label followed by memory and operands, and we have a command section. For example, we have a label with the name that is I'm going to have an input move R1 register, comma, hash symbol 25H. So the operand as well as the register, it's really mentioned. Actually, the procedure is, in this given example, from the source, it is copied to the destination. So the source is set to be as 25H, and the destination is set to be register R1. Here, the term indicates we need to load the data 25H into the register R1. Hope you do understand. Um, First, before we discuss about the instructions set programming, at least we want to know the structure of assembly language. I just give the syntax of the assembly language. For that, we have an example. That example deals with it loads the data 25H, that is particular with the help of the immediate hash indicates the immediate addressing one. So the value, the contents, whatever it may be, it is to be it is to be loaded into the register called R1. And we want to know some registers before going to have a discussion the remaining terms. Registers A, B, and starting from R0 up to R7. And in addition, DPTR and program counter register. These are all some of the registers. And as I said before in the previous slide, move destination command source. From the source, it will move to the destination. We have certain examples, move A, comma, $55H, and move R0, comma, E, move A, comma, R3. We have certain examples. We got it based on the given syntax given. And followed by instruction groups. Actually, the 8051 have 255 instructions. Every input is an 8-bit opcode in your microcontroller based procedure, starting from 00 to F, that is said to be an hexadecimal mode, except A5. And the instructions are mainly grouped into 5 groups. One is arithmetic instruction, logical instruction, data transfer instruction, and Boolean instruction, and branching instructions. Then we have a discussion about each and every instruction separately along with some examples. First one is arithmetic instruction. Arithmetic, people well know that arithmetic, it indicates addition, subtraction, multiplication. These are all some basic arithmetic instructions. For example, in that, in this, I'm going to have some input set to be an operation of add, comma, add C. So add in the sense, we need to add some two values. Add C in the sense, add accumulator with the carry. So generally, I'm going to give the instruction called add instruction. It will add from the source to the destination. That is whereas add does not add the carry flag to the result. So that is the meaning. So simple example, followed by data transfer instructions. So in data transfer instruction, I'm going to have an operation MOV, move destination, comma, source. This instruction copies the data from a source location to a destination location. For example, we have an example, move AX, comma, BX. So it means that BX copy the contents of the register present in the BX register into the register called AX. So the meaning is whatever may be the contents available in the particular register called BX, it is to be the content will be copied to the exactly the content will be copied to the AX register. So that is the meaning for the term. And one more example, ARM assembly with R0, R1. So anyhow, R1 copies the value in the that is a value in register R1 in the register R0, that is R0. So this is the meaning for this one. An instruction call, that is the data transfer instruction, and operation is move operation. And the next one is store, STR, it may be STR, that is in short form. The instruction copies the data from a register to a memory location. Anyhow, from one register to alternate memory location. Say, for example, move 0x2000, BX. So what happens? BX store the value in register BX into the memory location specified that particular memory location 0x2000. This is the meaning for this term. And one more example, str, that is a command called str r0, comma r1. So it will store the value in the register r0 into the location pointed by the register r1. So this is the meaning for the term. So it's an example for your store data instruction. And the next one is push instruction. So push and one more instruction is pop instruction. This push instruction adds the data to the top of the stack. You know, well, what is the difference between stack and queue and what does it mean, pop and push everything. So push instruction, the instruction is, say for example, I'm going to give the instruction data instruction push AX. So it means that it pushes the value of the register AX on to the stack. Okay. And the next alternate one is pop instruction. This pop instruction removes the data from the top of the stack and places into a register or memory location. For example, pop BX pops the top value from the stack into the register BX. So that is the meaning for the term. So likewise, we have too many instructions will be the, say for example, we will go for some examples regarding this and followed by logical instruction. Logical instructions, you people well know, you people are aware of your instructions such as logical instruction, arithmetic instruction, but in microcontroller, what type of data set instructions used, what type of logical instruction, just we have a brief discussion about that. So logical instructions operate on data at the bit level. Every data instruction will be in the bit level only, performing operations like AND, OR, XOR, and NOT. These instructions are used for tasks like data comparison, masking, as well as encryption. For example, I'm going to have AND instruction and OR instruction. So, AND instruction, that is AND operation, performs a bitwise AND operation. For example, AND R1, R2. It would perform a bitwise AND between the contents of the register R1 and R2. So, storing the result in R1. If both corresponding bits are 1, then the result is 1. Otherwise, the result is, if it is 0, anyhow, it is not possible to proceed the procedure, what I said. So, anyhow, at the time of performing the AND bitwise operation, say for example, AND R1, R2, it will perform the AND operation between the contents of the register R1 and R2 It will store the result in R1 if both corresponding bits are 1. That is, if the result is 1, or else it is 0. And the next one is OR operation. It performs a bitwise OR operation. For example, R1, comma R2, it will perform a bitwise OR between the contents of the register R1 and R2. So in this, as a alternative one, actually, and comparatively is the AND operation, storing the result in R1. If either corresponding bit is 1, then the result is 1. Otherwise, it is 0. So people well know that that is the truth table. That is what is the value of 100, 1, 0, 1, 1, and then 0, 0. Okay. Just we need to follow the same procedure what we have the truth table, and then if the result is 1, or else otherwise if it is 0. Okay, if the result is 1, it can store the value, or else if it is 0, it's not possible to proceed the same. And followed by Boolean instruction. So Boolean instruction in an embedded are used for bit level manipulation, enabling the operations like setting, clearing, complementing, and testing individual bits within the registers or memory location. So you people well know that Boolean values, only two values are there, whether true or false, whether if it is 0 or if it is 1. So it is a basic thing. In embedded system, everything that is, as I said before, is a bit level is a bit level operations only. That is a manipulation, enabling operations like setting, clearing, complementing, and testing the individual bits within the register or memory locations. Say, for example, I have an example, setting and clearing bit example. For example, we have an instruction called set bit, that is the set B bit address. So it means that that is sets the specific bit to 1. For example, set B P1 dot 0. It would set the bit 0 of port 1 to high. If it is CLR bit, for example, clear bit address, it clears the specified bit to 0. That is, in alternate one, set bit, we need to set P1 dot 1 and 0 in the sense that it will set to port 1 to high. Here, it will set, that is, for example, it will clear P1 dot 0, that is clear P1 dot 0 on the side, it will clear bit 0 to port 1 to low. Say, for example, this is an example for set bit as well as clear bit address. And the next one is branching instruction. Branching instructions, that is the next instruction, apart from Boolean one. So in the branching instructions in embedded system allow the program flow of execution to be altered based on the conditions, or it may be some types of unconditional one. Say, for example, if you are going to deal about conditional one, example, it includes conditional jumps. Say, for example, I'm going to give an instruction called JZ, that is jump if 0, and JN is a jump if not 0. That is the basic difference. JZ in the sense jump if 0, JN is in the sense jump if not 0. So we have an example based on this. For example, I have an instruction that is in a conditional branching one. We have an instruction. The instruction conditional branching, this instruction check the status of specific flags like the 0 flag or carry flag, etc. in the processor status register, and jump to a different part of the code if the condition is true. For example, 8051 JZ label, jump to the instruction label if the accumulator's value is 0. If the accumulator value is not 0, the next instruction in the sequence is executed, followed by unconditional branching. The unconditional branching instruction jump to a specified address without any condition. That's why it is said to be unconditional one. The program counter is updated with the new address and execution continues from that point. So B label example unconditionally jumps to the instruction labeled particular label. That is the meaning for that term. Label indicates the address, the particular address. And after the discussed all these 5 types of instructions, starting from We have an arithmetic instruction, data instructions, and followed by Boolean instruction and branching instruction. We need to have some information regarding what are all the advantages of instructions of a microcontroller and what are the disadvantages of instruction set of a microcontroller. For example, advantages. We have three advantages I specified mainly: efficiency, low power consumption, versatility. Efficiency deals about an architecture such as that of ARM uses a reduced instruction set RISC that facilitate fast and efficient operation. That is said to be an efficiency. If it is a low power consumption is typically very, very important in embedded system. And therefore, the system has been designed with optimum power use in mind. So, with the low power consumption, that is said to be one of the advantage. Versatility, the third one. The different forms of instructions are possible to accomplish a number of operations. It's said to be versatility. Anyhow, the three main advantages are efficiency, low power consumption, and versatility. Followed by we have disadvantages. Disadvantages of instruction sets of microcontroller. Mainly we discuss about two type of disadvantages, two disadvantages. One is limited flexibility as well as hardware dependent. Limited flexibility in the sense some micro operations involve many instructions as the level of operation becomes high, hence more complex. It is a limited flexibility. Hardware dependent in the sense the various microcontroller families around have their individual instruction sets, something that makes them incompatible. So there are two main disadvantages we have. One thing is limited flexibility and hardware dependent. Guys, we discussed today 8051 microcontroller data set, that is the instruction set as well as the programming based informations. Basically, we discussed some five types of instruction sets and followed by we discuss what are all the advantages and what are all the disadvantages. In the upcoming session, we have a discussion about 8051 microcontroller programming based on the data sets. That is the based on the instructions, what are all we discussed. And also, what are the addressing modes available? There are five different addressing modes are there. Each and every addressing mode, we have a specific function. So we have to discuss the following in the next session. Thank you. Thank you all.